So we've discussed the practice relevance, we talked the research relevance, so now let's talk about how can we construct and refine the tests so that they are reliable. And reliability is really an important factor because it's important to have precise measures, right? So it's an important consideration when we construct and refine tests. Now, there's different things that affect the internal consistency, right? There's one is the test length, right? With everything else being equal, longer tests will produce more reliable scores than shorter tests. And then also the consistency of parts amongst the test. A test with greater internal consistency will provide more reliable scores than a test with lower internal consistency. And so we'll discuss more about what statistical characteristics of a test item that we examine to identify items that should be removed from a test, or to look for items that should be revised or enhance their contribution to a test's psychometric quality. So when we do the psychometric analysis, we would do it for a dimension, right? So if it's a unidimensional test, we just do it for all the items of that dimension because there's only, there's one. But if there's multiple dimensional tests, then we do the analysis for each dimension. And so we use the particular instance of data collection to improve the use of this test for further usage. However, it's also important to keep in mind that the sample that you're using might have certain characteristics with it that might have some biases as well. So that's important to keep that in mind. So typically what we do is we look at the degree of the consistency of the test items, and we look at a correlation matrix between the items, and we also look at if they contribute or detract from the overall reliability. So as an example, right, you can look at the correlation of the test items with each other. You can look at a correlation of the test item to the overall test score, right? And we also typically can look at indicators. For example, in SPSS, you get a Cronbach's alpha if the item is removed, right? So you can see what happens if we take this out. Does the Cronbach's alpha go up or down? So when you look at a certain test, you can also look at the item difficulty or the mean of that item, and also the item variance. And then you can look at the correlation, the degree of the variability among variables, right? And see how the variability of one variable is consistent with the variability of other variables. So the characteristic that we're looking at is really the inter-item correlations, the inter-item to the total correlation, and what I mentioned, the Cronbach's alpha if deleted value. This gives you an idea of how well the different items perform, and which one might be actually good to take out or which ones might be good to keep.